Okay, we are going to work on chapter 4.1, 3 and 4. So first in the problem, we are going to work on integral. So we are done with derivative. Now we're going to work with integral. Few words about integrals since I don't remember if I explained regarding derivative, I'll just cover both of them. So a couple of words about integrals and derivative. We use it in algebra when you know about distance. Let's say this is our distance, S, okay, and we have the speed, constant speed. Then we can find the time that is equal S over V, meaning distance divided by speed. Now, and accordingly, distance we can find if we know time, and the speed we get T times V. This is we can use in a case when speed is constant. But nothing is so easy in life. When you are driving, you are accelerating, you are slowing down. How to find in that case? Okay, so in that case, we are going to use derivative. Okay, let's say if you have a speed for in every second you have, so to find the speed while you are driving, so it's going to be dv by dt. Okay, so that will be the speed at any given time. It's going to be calculus that will take care of it. If you take a derivative of the derivative, let's say dv by dt, and you take another derivative, let's say prime, that is going to be your acceleration. By the way, this dv by dt you can also mark as a v prime, okay? But that's assuming that you know that's going to be by dt. That's the difference between dv by dt and v prime. When, let's say, we want to mention by which variable we are going to do derivative, then we're going to use this method to show that it's by dt. But when you put v prime, that means we have only one variable, and it's going to be automatically by dt. And this is acceleration. When you take the second derivative, meaning derivative of derivative, whatever derivative you got result, you take one more derivative. That will be acceleration. And if you take second derivative, let's say dv by dt, and the second derivative, 1, 2. Second derivative, that will be the calculating jerking of the car. Okay, so this is about derivative. Now, opposite operation, in this case, we are going to deal as an opposite operation. We are going to deal with integral. As an operation, it's opposite to derivative, it's going to be integral. Now, let's understand, where do we use integral? What is it? Derivative is participating in algebra in dynamic, okay? And integral is a geometry in the objects that don't have a right form. Let's say if we have a rectangle, well, it's not a rectangle, it's square, looks like. Let me make longer. Use your imagination. The sides are equal and parallel. So if this is x, this is y, let's say, then the perimeter gonna be twice x plus y. But what if we don't have such an object, but we have something like crazy, like this? Okay, well, which is gonna happen, let's say, in the car, right? You have very complicated shape of subjects, I'm sorry. And in this case, you can't apply geometry x plus y times 2. In this case, we are going to use integral. If I call this f of x, this the integral, then here I'm going to put integral of f of x. That will give me perimeter, f of x dx. If I take second integral, you can take twice, you can get n degree of integral. If I take second degree of interval, that's going to be area. Okay, this is a little bit information about integral and derivative accordingly. So integral is dealing with geometry, and the derivative dealing with algebra, dynamical in dynamic. So let's start working. Let me clean all this, or I can move to clean page, and let's start figuring out how we're going to work with integral. Let's say we have integral. Oh, it's very thick. Okay. Integral, let's assume we have, what integral we have? 11, hold on, how much do I have here? 9 dx. Okay, integral, we have 9 dx. So how we're gonna get integral of 9 dx? So if you can see, we have a constant, and we need to take integral by dx. So constant rule, here we are going to take the integral is an antiderivative of derivative. Antiderivative of derivative. So the rule of constant that need to be integrated is the following. So integral k, which is constant, dx is equal kx and plus constant. Plus constant, we always gonna add this constant c, because we know that derivative of constant is 0, and we don't know here there is constant or not, right? Because constant, when you take derivative, it's disappearing, becomes 0. Now, to double check this rule, if I take derivative of kx, let's look here, kx plus c prime, if I take it, what am I going to get? Derivative of kx is going to be k, derivative of c is going to be 0, right? So we got what we have under derivative, k dx. Well, dx we put, so you will know what derivative was by dx. All right? So, following this rule, what we are going to get? We are going to get 9x, right? X coming back. As you go, derivative of 9x is going to be 9. Yes? Okay, 9x and plus constant, plus c. So, real quick, another example. If you have, let's say, 24 dx, it's going to be 24x plus c. Yes? Okay. Question number 2. Let's move to next question. We need to put it, the answer. Let me put the answer, 9x plus c. 9x, where is plus? Plus uppercase c. Well done. Moving to next question, x cubed dx. X cubed dx. how we are going to solve this question. Let me put a little bit higher. X cubed dx. So the formula here we are going to use for power, it's going to be integral of x to power n dx. Remember what we were doing? We had derivative of x to power n. It was n times x to power n minus 1. Since we are doing opposite operation, everything is going to go vice versa, right? Opposite. So we are going to get, instead of n minus 1, we are going to get x to power n plus 1, and we're going to divide by n plus 1 instead of n. Okay? This is going to be the answer, n plus c. Yeah, here we had only n, but we divide by n plus 1. And we are assuming we're going to have condition that n cannot be equal to negative 1, right? Otherwise it will convert to 0 denominator. So from here we have, let's solve it, x to power 3 plus 1 divided by 3 plus 1 and plus c. So from here, I want to make space. So from here, it's equal x to power 4 divided by 4 and plus c. Yes? Okay. Moving to, okay, let me put the answer. X to power 4 and all this. I am dividing, I put direct slash to show division, dividing by 4. And we do plus c. Excellent. Okay, moving to question number 3. So what we are going to have here, x squared minus 9x plus 4. Okay, let me write down. X squared minus 9x plus 4 and dx. All right, so in such case, all we're gonna do, I'm going to, this time I will break into steps so you can see, but later on you already will know. So I can break down, when it's come to integral, you have polynomial here, right? I can write down integral x squared dx minus integral 9x dx and plus integral 4 dx. Okay, and we are going to use our formula, right? This one that we have. So let's do it. This is going to be equal. So I will get x squared, so n is 2, 2 plus 1, I'm getting x cubed over 3 minus 9x, meaning 1, right here, degree 1. I'm solving this one. So it's going to be 9x squared over 2, right? We do plus 1 and dividing by 2. And here we have derivative, integral of 4. So it's going to be here. K constant, kx plus c. So it's going to be 4x. And at the end, we are adding C, constant. How many constant? This is C. It shows a cumulative constant. There can be several constants. For every single, it can x cubed divided by 3 plus C, 9x squared divided by 2 plus C, 4x plus C. So we just take out plus C altogether. So how many ones they have? It doesn't matter. I can put here C1 plus C2 plus C3 equals C. And this way I can, let me see. So add here, if it make clear to you, plus C1, okay? And then this one, because every single one of them is gonna be with constant, so it's gonna be plus C2, and I can put this C3, and not to have so bunch of C's, a constant, so I'm going to write down this way, and it's gonna be the same thing I put there. X previously I had x cubed over 3 minus 9x squared over 2 plus 4x and plus cumulative constant. Okay, so let me take a picture. I know myself, I'll mess up definitely writing result. So I took a picture. Now let me plug in here, and I am getting x cubed x to power 3, and all these I am dividing by 3, okay, and then it's going minus 9 x to power 2, and all these I am dividing by 2, and then we go plus, I guess I can get rid of that space, huh? Okay, let me go, no, all right, I thought I left their space, so I didn't, plus 4x. And plus our uppercase C, which is constant. Let's check. What did I, oh, wait a minute, it wants to break down. I don't understand. Let me double check. X cubed by 3, 9x squared by 2 plus 4x plus C. Well, find the integral. I found altogether 9x squared plus 4x. Is it possible, checking again, use property, well, we did. Let's see which way they want. I'm pretty sure it's about notation. Ah, okay. So everything is correct. It just they want to put 1/3 instead of over 3. It's the same thing. So now you see the way they want, and you put that way. Okay, don't put the way I put. But it's a software. You can make them understand it's the same thing. Whoever wrote this program, they should know. X over 3 or 1/3 of x, it's the same thing. So I'm not going to solve another one. I'm going to move to next one. We consider it as a correct. Moving to question number 4. And what do we have here? The same way, so we will be careful. And if we have fraction, we are going to put in the format of separate, the coefficient we put in the format of separate fraction. Okay, so let's see what we are going to do here. I'm going to do, okay, I wanted to just put the answer, but I guess I'll go one more time, step by step. So we have integral 12x squared. This is number 4 we are solving, right? I'll put here integral 12x squared minus 8x plus 4 and dx. So 12x squared, it's going to be 12x cubed over 3, right? 2 plus 1. Here is our formula. There we go. And plus 1. N is 2, we put plus 1. We'll get 3. Now 12 and 3 I can cancel. This is 1, this is 4. So we got 4x cubed. Next, minus derivative of, integral of 8x. 8 is going to stay. And x is going to be x squared over 2 because degree here 1, 1 plus 1 and 2. And whatever we got here, we put here down here also. All right, so 8 and 2, this is 1, this is 4. And lastly, I'm going to, let me write real quick this clean before we get confused. It's going to be 4x cubed minus 4x squared and plus 4 dx. It's going to be 4x because it's 1. We don't put divided by 1, right? And it's going to be 4x and plus overall c. So, which means 4x cubed plus c1 minus 4x squared plus c2 plus 4x plus c3, and we combine again all this is and we put c. So this c we consider it's a sum of all constants that possibly can be there. Okay? All right, let's place the answer. We are getting 4x cubed what did I put, z? Okay, next it's going to be minus 4x squared. What's wrong? Keep putting z. Okay, and plus 4x and one more plus and c. Okay, nice work. Moving to question number 5, and what do we have here? 1 over x to power 13. Okay, question number 5. Integral 1 over x to power 13 dx. Hold on, let me double check just in case. 13, yes. All right. How are we going to solve this one? What do we have here? So I'm going to represent x to power 13. Let's do here drafting. 1 over x to power 13. If you remember from algebra, is equal x to power negative 13, right? Okay, so I'm going to rewrite integral x to power negative 13 and dx. That comes from formula real quick. X to power negative n is equal 1 over x to positive n. And accordingly, when you have x to negative n, it's going to be equal, you flip x to power positive n over 1, which is x to power positive n. Now you have here positive, that's mean here it's going to be negative. So because here you have negative, here is positive. So if you have positive, then it's going to be there negative. Okay, So x to power negative 13 dx, which is equal, I'm going to do it in details, x to power negative 13 plus 1, right? X to power negative 13 plus 1 divided by negative 13 plus 1 and plus constant c. Yes, we use this formula. Okay, so plus 1. Okay, so what do we get from here? Integral 1 over x to power 13 dx is equal x to power negative 12 and negative 12 here plus c, which is, let's improve, x to negative 12, it's coming as it's coming to x to positive 12, and negative 12, this 12 doesn't go anywhere, stay there, but this negative I put in front of fraction. So it's going to be 1 over 12 to power x to positive 12 and plus c. Okay? Let me write down. So it's going to be negative, and then 1 over 12 x to power positive 12 and plus c plus uppercase c. Well done. All right. So far so good. It's not difficult. Well, I don't know if you heard, integral can be very nasty solution, but in this subject we are not going to get into such cases. So we're going to learn fundamental questions here. All right. So we have dx, integral dx by x to power 6. Dx by x to power 6, which is the same thing. I am rewriting 1 over x to power 6 dx, right? So this is equal integral x to power negative 6 dx. So we're using our formula, so it's going to be x to power negative 6 plus 1 over negative 6 plus 1 and plus c. So from here, integral dx over x to power 6 is equal, negative put in front, this negative 5 stays underneath, right? And x to power negative 5 comes to the bottom with positive 5, right? And we are getting 1 over 5x to 5 plus c. And this is our answer. So 1 over 5x to 5 with negative. Let's do it, negative 1 over 5 x to power 5 and plus c. Okay. So next we are moving to question number 7. Let's see what we have in question number 7. 6 over x. Okay. Number 7. Integral 6 over x dx. So what do we have here? I'm going to write down this way, integral 6 times 1 over 6 dx. This 6 is going to get out anyway, so it's going to be 6 integral 1 over x dx. And we are reaching the integration formula where integral 1 over x dx, or you can write down this way, integral dx over x, and that is equal natural logarithm of absolute value of x and plus c. Okay, so this is accordingly, it's going to be equal natural logarithm, so 6 and then natural logarithm, hold on, of x and plus c. Okay? All right, let's place the answer, see how we got, how we did. 6 natural logarithm x 6, where is my, okay, now I need to find absolute value. Where is my absolute value? I'll put this way. Okay, so okay, natural logarithm of absolute value of x and plus c. Did we miss anything? Let me see. Let me go back. We did everything correct. Okay, let's go back and see what was that. I didn't read it. I'm going to open one more time and see what it says here. We did correct. Okay, so I'm opening answer. Let me see what it's gonna show me. Aha, space. I think they are wrong. There cannot be space there. They made a mistake. They put their space. Okay. All right. So we are good. We are right. So ignore this incorrect that it's marking down as an incorrect answer. After natural logarithm, you don't put space. You just put log x. Okay. All right. So yeah, quite a few mistakes. If when you do your homework and you will be caught with such mistakes and you know it's correct, send me a text message and mark down which problem, which question is this, which assignment, which question is this, and I'll give you credit back, okay? Because there are bugs in this assignment, I see. Number 8. What do we have here? Let me take a picture. We are going to find integral for value e. Remember when we did derivative, the e would stay the same, right? It wouldn't change. Derivative of e is e. Well, let's deal here. What we have here. Question number 8. And we have integral 7 e to power 10x and dx. Okay, how are we gonna solve this problem? First of all, I'm taking out 7, right? Because it's a constant. And I will have e to power 10x and dx. So let me write down formula for you. Integral e to power kx dx is equal 1 over k times e to power kx and plus c. Well, since we have division here, 1 over k, we need to, for safety, we put there k cannot be equal 0. Now, everything I wrote down with red color, those are all formulas, and I highly recommend write down in your notebooks. Okay? All right, back to our problem. And what do we get here? We are getting 7 times. Let me write down here so I don't have to squeeze. Okay, 7. Can write down 7 out, e to power 10x dx. It's going to be equal 7. Now, e to power the kx, it's going to be e to power kx. It just we divide by k. So our k is 10 here, right? This is my k. Next, k is 10. So it's going to be 7 divided by 10. And then times e to power 10x and dx. Oh, no, I'm sorry. 10x and plus constant c. So 7 over 10, we can't do anything, that means we arrive, this is going to be our final answer. Okay, let's place this answer here and see what we got. Let me take this. All right. And we are getting here 7 over 10. And then I would, if it would be up to me, I would put a 7 e to power 10x. But because I don't know this software is going to play such game with me again, so I'm just being careful. E to power 10x. And we put plus uppercase C. Let's see. See? Now, I bet if I would put in numerator e to power 10x, it would catch as a mistake. Because in other two problems, that's what it did, I think. Okay, this is question number 8. Moving to question number 9. Since total 20 questions, I will solve here 10 questions. And then in next video, I will solve another 10 questions this way. So it would be easier for you to rewind and forward, so find this or that question. So if I record another half also in one video, it will be much more difficult for you to look up the problem, right? So I'm breaking into 2 parts. So this way to make it easy for you. All right. What do we have here? A company determined that the marginal cost C prime, it's given in the form of derivative, producing X unit of product is given in the form X cubed minus 6X. Okay, I'm taking X cubed minus 6X. It's going to be our key equation, looks like. Find the total cost total cost function C. Okay, total cost function C, which means it's integral because it's given C prime, and we need to find C, assuming C of X is in dollars and that fixed cost is $2,000. Okay, so fixed cost is $2,000. That means we are going to add at the end, right? 2,000. It's going to be our constant. We already know that it's our fixed cost constant. That's our C cost constant. Okay, so let's solve this one. Question number 9. So we have C prime of X is equal X cubed minus 6X. So we need to find total cost C. So from here, C of X is going to be equal integral X cubed minus 6X dx. So which is equal integral, okay, I'm going step by step, X cubed dx and then minus integral 6x dx, right? And plus C for once we take integral. So how much is X cubed, the integral of X cubed? It's going to be 3 plus 1, right? Where is it? Here. N plus 1 over n plus 1. So we have C of X is equal X to power 4 over 4. Let me write down the way they accept it so you would see it. 1 over 4 X to 4 and minus 6. It's going to be X to 2 over 2, right? Like that. And we can cancel 1 and 3. And plus C, which means final answer is going to be C of X. Now, this C and this C is not the same. This one is a function C of X, and this one is constant. Okay? So C of X is equal 1/4 X to 4 minus 3x squared, and plus our C was 2,000, right? Okay, so this is our answer. Let me take a picture of it and let me plug it here in the answer. So we have, oh, here it is. One over 4, and then here I put x to power 4, okay, minus 3x to power 2, okay, plus $2,000. Let's check. Good job. And we have question number 10, and I will stop recording this video. Actually, next question is coming graphing, so I'll just better combine with other part that has graphing involved. Okay, so we'll stop by question number 10. I'm not going to do number 10. I'll record number 10 in my next video. It's just by topic. It's next half is going to be all graphs, so might as well we'll do in next video. Okay, see you in next video.